In this demo, I will play the role of a telco data analyst who needs to combine various and complex data sets together to produce as many predictors to build and tune a predictive model to identify the reason customers may churn and prevent it before it happens. With simplification in mind, the demo will focus only on customer information that is coming from a transactional system, account activity, and more specifically the call detail record log that contains information such as unwanted drop calls, and social media activities, in particular tweets referencing US telco from which I can derive a sentiment score, which can be a good predictor of churn. I'll be leveraging Cloudera Enterprise Data Hub to search, store, process, and access the data at scale. Trifacta sits on top of Cloudera to discover and profile the data, then structure the complex data into discrete attributes, so it can be cleansed, normalized, enriched, and combined with additional data sets to be distilled in a way that BI tools or other machine learning frameworks can leverage the data. The demo will focus on the particular process of preparing the data from Hadoop so it can be consumed for predictive modeling. The data I'm working with are in different file formats, which are complex and often changing. It's hard to clean the data and derive insights such as sentiment score from a conversation. To add to this complexity, these come in huge volumes, so it's hard to manipulate the data. So far, I've been relying on programming languages and ETL data engineers to do this work for me. Because they don't know the context of the data, my current process creates far too many frustrating cycles before I can actually get the data right and provide insight to my business. With Trifacta, let's see how I can easily format these files into discrete attributes so I can derive insights quickly. Let's start with the customer data that is coming from our transactional system. This data is pretty well structured. As a data analyst pulling up this data in Trifacta, I'm immediately presented with the data in a familiar grid interface. Trifacta automatically identified signals in the data to split columns and lines. It also automatically infers the data type of each column and presents a data quality bar communicating the relative quality for each attribute. In this particular case, Trifacta was able to detect the comma as a separator and identify the header for each column. For this analysis, let's take a closer look at our customers. I'm taking a look at the column details here for the state column. I'm presented with the data distribution and a visual distribution of the data in the US. Because I'm interested in churn prediction, there's no need to keep inactive customers in my data set. So let's select the inactive customers in the status column. Thanks to predictive interaction, Trifacta identifies the user's actions to recommend the best transformations to be applied to the dataset. For example, splitting or extracting a column, keeping or deleting rows, or replacing patterns in a column. Trifacta visually shows the distribution and suggests that I keep the data I selected. In this particular case, I will select delete instead of keep. Let's now switch to the CDR log so we can also format it and combine it with the customer information. The CDR log file is a way more complex structure and in theory more difficult to handle. If you look at the top here, you can see that Google thinks the file is in Norwegian. But let's see how easy this is with Trifacta. Look how Trifacta is able to learn by example. I first select the IMSI, and Trifacta suggests a transformation. Then I brush a number, and it's getting closer to what I want. When I select the third value, Trifacta got the exact selection across rows that I was looking for, so I'll add that to my script. Also notice how easy it is to format the columns. Trifacta's inference engine deduces metadata to the specific data type for each attribute and presents a data quality bar communicating the relative quality of each attribute of the data. We're also presented with an intuitive visual representation of the data distribution in each column in the form of a histogram to show the relative frequency of terms. Let's finish cleaning up these columns. I want to head over to column 3 and highlight this slash. I'll choose split and add that to my script. Then I want to select this colon in column 4. Again, I'll add split to my script. Lastly, I'll select this slash in column 5, and again add the split to my script. If we look over at column 1, we'll see that Trifacta has inferred that the column should be a string data type. We actually want it to be an integer, so I'll select integer from the data type dropdown. But now we'll see that we have some mismatched values. If we click on the mismatched values, Trifacta will highlight the rows where the mismatched values are present. We'll notice that these rows are the ones containing the dashes, so we'll brush over the dash, select to remove it, and now we have what we want. Lastly, if we look at column 2, we'll notice that there is a missing value. If we click on the missing value, Trifacta highlights the first row. If we then click on the first row, it will suggest to move the row into the column headers, so let's do that. Trifacta's self-service predictive interaction empowers the data analyst to be more productive and provides faster value to the business. With this well-structured format, the data analyst can now discover in greater detail what the data can reveal. In addition to its unique predictive interaction ability, Trifacta enables the user to discover data and clean it through interactive profiling. It will bring the data to the next level of accuracy for trusted and focused analysis. In this use case, the data analyst will be researching dropped calls in order to prepare the data to research possible customer churn. You will see through interactive profiling what the data distribution is, whether or not there are outliers, what correlations are present, and what anomalies need to be remediated. I'll now go back to the CDR log file. Because I'm interested in dropped calls that may be a factor of churn, I will try to isolate this information to identify from further analysis some possible repetitive patterns. As I am continuing to browse the column header, I can quickly identify that some data is missing from the column disconnect reason. By clicking missing values on the column header, Trifacta highlights the rows with SMS and MMS. Let me get more information about call types now. By selecting the column details for call type, I can access statistical information about that particular column. Mismatched values, value distribution, min, max, etc. Since SMS and MMS are not calls, they're not important to my analysis. So now if I click on SMS, Trifacta suggests that I keep the values, but since they're not important, instead I'll decide to delete them. Now I'll head back up and select MMS and do the same. Whoops, I just added keep instead of delete. Luckily, that's not an issue with Trifacta. You can always reverse to any point in your transformation. Let me go up to the script and undo, and then add delete to the transformation and add that to my script. Now that I have cleaned up my CDR data, I can now work on preparing my next data set. I will focus on the tweets my company is collecting continuously to derive a sentiment score. This information is also unstructured and needs to be formatted into discrete values so I can apply some natural language processing algorithm to derive a sentiment score out of the conversation to be used as a predictor for my churn model. Twitter provides the feed using a JSON format. JSON is a semi-structured format containing value pairs, lists, and objects. Similar to the CDR data, I will start to structure the file into discrete values so I can derive some insight. As you can see, Trifacta provided me with two columns, Twitter info and user info. I mouse over the first column to discover what information is available and select Twitter text value. I select the unnest transformation and drop the initial column. I now mouse over the column user info to extract the user ID. I unnest and drop the initial column again. While discovering and cleaning the data analyst grows his data perception and strengthens his trust for further analysis. Ultimately, it will reduce analysis risks by delivering trusted, accurate, and consistent data for building new insight. With trusted data, your business can be more confident and agile in its operations, basing business decisions on reliable, high-quality data. Let's now augment the data with additional information. Let's go back to the Twitter feed file where we left it. We now want to derive a sentiment score based on the tweet text. With Trifacta, I can call a user-defined function to extend Trifacta language. In this case, I'm using a Python public library from www.nltk.org, a very used and recognized natural language processing library. In the transform editor, I can directly enter the wrangling script. Look how Trifacta also guides me in suggesting the correct syntax. I can now add this transformation to the script. The function returns a JSON format with a general trend for the message, either negative or positive, and then the respective negative and positive score. I can click on the histogram on the negative value and only unnest this particular value pair from the object. I add it to the script and drop the Pi sentiment analysis column. I'll now brush over the long tail of negative values just to focus on the high negative sentiments to keep those ones from my model. I add the keep suggestion from Trifacta to my script. Reading the comments, I can see that the comments are actually pretty negative. This information will be a great predictor to build my model. Moving back now to the CDR file, I will translate disconnect reason code into a descriptive label that non-specialist users can understand. I'm using the lookup function and select the drop code cross-reference table. As you can see, Trifacta added an extra column with plain English labels. Let's now combine the CDR log with customer data that we wrangled already. I can join it with the CDR dataset to augment it with some new predictors. Clicking on the hammer icon, I have the option to join or aggregate data. I will use the join wizard to help me with this. I'm now offered a list of datasets that I can join with. Let's select customer and preview the new dataset and then begin to join. Trifacta automatically infers the best columns that can match between the datasets based on the content and format. It suggests IMSI as the best match column. Let me add in all the columns, and then I'll click Add to Script so the join is actually executed and appends these columns to the CDR dataset. I'll also need to drop the IMSI column that is duplicated. Let's now add the sentiment score from Twitter to this combined dataset to create a superset that I can use in my predictive churn model. Selecting the hammer as I did for the previous join, I'm now adding Twitter to the dataset. This time, Trifacta didn't find the best column to match. This is probably due to the fact that too few people have Twitter accounts. However, we can edit the join criteria to select manually the column to match. By selecting Twitter as the join criteria, I can now see the corresponding values. I can also see that the resulting dataset for the join will be reduced. The reason being that not all customers have known Twitter accounts. In order to keep all the customers, even if the join condition is not verified, I changed the join condition to left outer join. It will keep all the customer data, even if the join is not verified. You can see now that the resulting set is way larger. I'm saving my condition now, as it gave me what I want. I don't need all the columns to be in my resulting dataset, so let me remove the Twitter ID and Twitter text from the columns and then add that to my script. There we go. Now I've combined the CDR data, customer details, and their sentiment scores. That will be very useful for me to find some churn patterns. By augmenting, normalizing, and combining multiple datasets of various formats, the data analyst got to create a comprehensive view of the customers. More predictors are now available to detect churn and use it for analysis. Row data, even cleaned and formatted correctly, is not enough to deliver all its business potential. Data has to be enriched, correlated, and standardized in a way that business people can understand it. The more comprehensive the data is, the deeper the insight will be, better allowing data products to be accurate and robust. With huge volumes of data, it's impossible for anyone to comprehend the whole set all at once. Trifacta proposed intelligent execution, so the data analyst works on a representative and manageable dataset, and then applies his rules on the whole set for comprehensive validation. The user can then export the data to business users through BI tools or other preferred publishing mechanisms. Through Trifacta Intelligent Execution, we will discover how self-service can be extended to huge amounts of data and how it can be exported to other users. You will see how to sample data, run transformations at scale on Hadoop, see the result, and re-ingest anomalies back to the sample, then publish the dataset in various formats such as SQL or Tableau. Let me go back to the transformer window. As you can see at the top of the screen, I've been working on the top first rows of the dataset. But since then, I've removed some rows and joined the CDR data with the customer data, so the data distribution may not be reflected anymore. I can refresh the data to get a better targeted set and continue my preparation work. Trifacta is creating a new sample dataset behind the scene, and so I can continue working. When the sample will be ready, I'll be able to refresh my working space. Let's now assume that I'm happy with my current transformation work. I want to apply my wrangling rules to the whole datasets. I can run the job locally, so Trifacta will execute the job, or if the amount of data is really large, I can leverage the unlimited power of Hadoop to run the job. I previously ran the job to save time, so I'll analyze the results. In the job results screen, I get a good overview of the dataset. First, the number of rows, the size that was processed, and the data type and distribution of each column. What strikes me immediately is the percentage of anomalies and missing values. Trifacta displays some sample rows to demonstrate what data has these issues, and I can now ingest these sample rows into my transformation project to further refine my rules. Let me click Add Sample Rows to the transformer so this data is brought back to my project. I may also want to share my work with the rest of the team, or just export it so it can be used for another process, such as building the model for predictive churn. By clicking Export Results, I'm offered to export the dataset as a JSON or CSV file. I can also create a Tableau TDE file that is native to Tableau. Ultimately, I can give a name to the table that will be created in the H catalog, which is the way to access the data through SQL and Hadoop. This will enable me to connect any BI tool supporting SQL for reporting. By combining multiple datasets of various formats, the data analyst got to create a comprehensive view of the customers, creating more predictors to detect churn. When it comes to making decisions on data, it's important to have the complete perspective and not to base it on partial information. Trifacta allows the data analyst to achieve his preparation at scale on virtually any volume of data. Ultimately, basing analysis on comprehensive datasets helps to ensure accurate and trusted business decisions. In conclusion, Trifacta allowed me to combine large amounts of customer information from various sources and transform it all into clean and structured data ready for use in our 360-degree customer churn analysis. Thanks for watching.